Okay, hello everyone. My name is Abdullah Zoghbor, and in this lesson on PowerPoint, we're going to talk about the introduction to geothermal energy in general for the class of EGE 497. So what will be covered in this PowerPoint are 8 points or topics. The first one being what is geothermal energy. I'm going to go into just brief a very brief explanation as to what just geothermal energy is and how geothermal energy is produced. And then the second point is going to be how geothermal energy works in the 3 different power plants that we're going to talk about. They all work the same way, except that each has just a different form of extraction of water, if you want to look at it that way. And then the third topic is going to be how geothermal energy works in heating structures. So instead of it going into a power plant, we're going to talk about how it goes into a building or a structure to either heat or create electricity as well. The fourth topic is going to be the historical role of fuel. We're going to talk about how, just since the Industrial Revolution, how just our energy demand and production and consumption changed along with our population growth. And we're going to talk about how this is the reason why there is a push into renewables, even though renewables aren't as effective as fossil fuels in today's world. Um, the fifth point is going to be the carbon dioxide emissions and climate change. Um, Again, that's going to be a point for renewables and geothermal energy as opposed to fossil fuels. And then the sixth point or topic is going to be the geothermal energy emissions. There's going to be a graph comparing the different levels of emissions, or I think it was CO2 emissions, just to give just a brief explanation, I guess, as to the difference in fossil fuel generation and renewables. And then there's going to be feasibility of geothermal energy versus renewable. That's where we're going to talk about how geothermal kind of outshines renewables, specifically solar panels or photovoltaic panels, and wind turbines, because their fuel, which is either sunlight or wind, isn't necessarily available 24/7. And even when it is available, it differs based on its intensity, so that can affect um, energy production, and that's a problem when it comes to flexibility of power grids. So we're going to talk about how geothermal kind of uh, defeats that, and then finally we're going to talk about the reasons to expand into geothermal energy uh, and its pros, basically. So yeah. So to start things off, geothermal energy is basically heat derived from either lava or just underground molten. And there's a small history behind it. It's basically from the formation of the planet 4.5 billion years ago, and from the radioactive decay of naturally occurring radioactive isotopes. Just an interesting fact. And then geothermal energy can be, again, used in either heating structures or buildings, or it can be used in large scale geothermal power to produce electricity. Or, yeah. And then some characteristics of geothermal energy is that it is, when the water is extracted, it tends to be used between 93 to 370 degrees Celsius. Geothermal energy is considered renewable, if you haven't caught on to it by now. And the reason for that is the water doesn't really get depleted, it gets put back into the system. The heating of water is done primarily through conduction, mainly. Um, and then just another fun fact is that geothermal energy is actually a driving force between the creation of mountains, or and it can melt rocks basically. And one of its biggest advantages, just as we talked in the table of contents part, is that it is constantly available. You can think of it as a nuclear generator where it produces the same amount of energy no matter what time it is, what day it is. And there's a small problem to it that we will touch on later, but it's basically it produces a constant amount of energy in general. So before we continue on to the rest of the PowerPoint, I want to show you guys a video that kind of summarizes what geothermal energy is in a more clear uh, way instead of me, I guess. So, yeah. No, whoops.
You may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
So, I just remembered for some reason. I don't have it on my slide, but they talk about how some plants produce sulfur as a byproduct, and you can sell sulfur. I found it interesting because when I interned at a gas processing plant that dealt with H2S, they also had sulfur as a byproduct, and they managed to utilize it to they used it as fertilizer or something. I don't recall correctly, but it was basically a byproduct that could be sold as well. So that's another form of revenue that could be used in addition to producing electricity. So as you can see, it has geothermal can be used in more than one way and has, more than one revenue source, I guess. Now, I'm going to talk about the three different forms of power plants. Yeah, this slide just talks about in general how water is heated through magma. As you can see, geothermal reservoirs are pools of water heated by magma deep below the surface. Water or steam can escape from cracks in the earth in the form of geysers or sometimes as magma from a volcano. The ability to harness the steam is what powers the geothermal power plant. So yeah, moving on to the three basic power plants. The first one is gonna be the dry steam power plant. And the dry steam power plant, it works by utilizing the steam from the water from underground without pumping the water up. And that steam is used to move the turbine. Again, it uses a steam Rankine cycle basically. And once the turbine utilizes that steam, the steam is condensed back into the reservoir basically, and it's just a constant cycle. So that's one of the power plants, and actually this power plant accounts for almost half of all installed geothermal plants. I don't exactly know the reason why. I guess it's maybe economically more feasible, maybe. The second point, or sorry, the second power plant is going to be the flash steam power plant. And the flash steam power plant differs from the dry steam one by it pumping up the water itself and not just the gas, or sorry, the steam. And how it works in a more technical, in more technical details, I guess, is when the water is pumped up, the water is extremely hot, and when it gets pumped up into that tank, because of the change in temperature, that causes vapor to form, and that vapor is then utilized by the turbine, basically. And once it's done being utilized by the turbine, follows the same thing, gets cooled back, and falls back into the injection well. Again, all of this uses the steam Rankine cycle in general. And then finally, the last form of power plants that utilizes geothermal energy is the binary cycle power plant. Now, the binary cycle power plant works kind of similar to the one before, the flash steam power plant, except there's one small difference. So in addition to pumping up the hot water into the tank, instead of it just being a cool tank that utilizes that vapor from the difference in temperature, it has another pipe in it that contains another form of chemical compound. And usually that chemical compound, for example, like isobutane, boils at much lower temperatures than water. That's where the ORC, which is the organic Rankine cycle system, kicks in. So it follows the exact same cycle as the steam Rankine cycle. However, the only difference is instead of using water and water vapor to move these turbines, you're using the vapor from that organic compound. And then when you want to recycle back these two different like liquids, they follow the same process. The water gets cooled back into the reservoir, and the chemical compound gets cooled back into its just tank, basically. So yeah, I guess that's for just the production of energy through power plants. And now for the production of energy through homes, or utilizing the heat for either heating or cooling as well, these structures. So there's a closed loop. There are three closed loop systems and one open loop system for geothermal heat pumps. And I'm sorry, the geothermal. Okay, so there's three kinds of closed loop systems, as we can see in front of us. There's horizontal, there's vertical, and there's the pond lake one. And the horizontal systems tend to be the most cost effective for residential areas. And for larger scale, as you can tell from the picture, the vertical closed loop system would be better to use, as it can go a lot deeper and utilize more wells in a sense. And the cheapest form is the pond lake one, but as you can tell, it's not as easily or readily available as the horizontal and vertical one, because you need to kind of be next to a pond or a lake. Now, in general, closed loop systems uh, would add antifreeze in winter. Reason for that is so the water just doesn't freeze, because the water that comes from the bottom of the earth is going to be warmer than the air that's outside. And then in summer, the pipes actually draw heat away from the building and it is absorbed into the earth or water. And because the fluid is already cool in the summer and warmer than the air in the winter, the heater or AC system doesn't have to work as hard as it would had it not utilized that water. And then there's the open loop system, which basically is just an open loop system, really. Water is taken directly from a source and into the heat pump. It is then recycled back out into the same source. And yeah, so for the historical role of fuel, I will put in my second part of the presentation. Okay, hello everyone, welcome back. So in the first part of the video, we talked about the in general, different kinds of power plants, how geothermal works, and the closed and open loop systems. I found a good video that kind of summarizes the open and closed loop systems, and I feel like it will be a good watch just because I showed you guys the video of how different power plants work, and now I kind of want to show you guys how the open and closed loop system works, just in case I've left out any specific information or whatnot. So without further ado, here we go.
In today's homes, comfort and efficiency are necessities, and how you will heat and cool your home are major decisions. Consider this 5,600 square foot home. It costs less than $70 a month to heat.
Well, when I built my home in 2000, I wanted to make sure that I would have very low energy bills because I intend to stay here for a long period of time.
Most of these energy bills are for heating, cooling, and hot water.
Looking at the way energy prices were starting to creep up, I felt that the geothermal system offered the best possibilities for energy savings.
Geothermal energy systems use the natural warmth of the earth to heat and cool your home. Nearly half of the solar energy that reaches the earth remains stored in the ground at a constant temperature of about 50 degrees. With geothermal technology, there are two basic ways to capture and use this heat, with open-loop and closed-loop geothermal systems. Open-loop piping systems are used in rural areas with a well. In other locations, closed-loop systems are most common. They use a piping loop installed underground or in a pond, depending on the size of the property. Each closed-loop piping system can be placed horizontally, vertically, or with a directional bore to absorb the earth's heat and move it into your home. During the winter, a geothermal energy system delivers heat from the earth to a furnace. The heat is compressed to a higher temperature and moved through the home by forced air or radiant floor heating. During the summer, the process reverses. The geothermal energy system removes the heat from the home and deposits it into the cooler earth. The result is a cool, dehumidified home.
Well, the first benefit that we looked at was the cost savings. In this home, our differential between doing a conventional system versus geothermal was about $10,000 more for the geothermal system. I'm spending about $60 more per month in my mortgage, but I'm saving about $110 to $120 a month in energy.
And those savings are pretty typical for homes with geothermal in Michigan.
But then when we looked further into the systems, we found that they're really environmentally friendly. Because we use renewable energy from the ground, we're not having to rely on fossil fuels. And since there's no combustion, it's very safe as well, so there's no risk of carbon monoxide in the house.
Geothermal energy systems are quiet, dependable, and safe. They have few moving parts and require little maintenance.
We get our system checked about once every 2 years just to make sure it's operating at its peak performance. And so far, there's been no problems at all.
Geothermal energy systems also have no outdoor equipment. They maintain a comfortable, even temperature in the home, and they provide efficient, renewable heating, cooling, and hot water.
Well, the number one recommendation is that these systems, through their energy savings, pay for themselves. And it's just a smarter way to use our resources today and not use as much energy for heating and cooling.
So, in general, it just summarized the open and closed loop system, and I found an interesting point actually. Uh, the person or the presenter talks about how this was built around the 2000s, and he built it in terms of to save on electricity. Basically, why it's just general consensus as to why people build renewables as well. They put solar panels on their houses to kind of reduce their consumption from the power grid. At the same time, they'd be saving money because there could be incentives, or it's just, yeah, they'd just be using less from the power grid. Now, what I found interesting, or what I found uh, as a good talking point, is how he talks about it was like the geothermal system, the open or closed loop geothermal system of heating and cooling their structures, or even using it for electricity, is it was competitive back then. So I decided to look at the oil prices while the video was playing around the 2000s to see if maybe oil prices back then were too expensive, which is why geothermal was competitive. Keep in mind that this technology, the one he's speaking about, is around a decade old from the time this video goes up. So by then, obviously, technology could have improved a lot. But in general, what I found was that oil prices were hovering around the $30 mark. Now, I don't know how much it is in today's world when you account for inflation from that day's price, from the 2000s price. However, the price of 1 barrel of oil in today's price is $50. So if we were to be very generous with inflation, um, I'd say back then prices of oil were even cheaper than today. And if these geothermal systems were pretty competitive back then in terms of saving money on their operations and cost, then definitely with today's advances in technology and the slump in oil prices and gas prices, this technology can still be competitive even when oil prices do increase, because just based on the math, uh, it should still be feasible and viable, basically. So with that being said, we're going to move on to the actual point of the second part of this video, which is the historical role of fuels, the CO2 emissions, and just emissions in general. Now, to start things off, reason why fossil fuel use is reason why we use fossil fuels, I'm sorry, is because of the energy density which it has. It's greater than biomass. Okay, the reason why I put biomass there is because it's believed that the first form of energy ever used by humans was biomass. So the transition from using biomass into fossil fuel was a big change in the industrial world, because you just have a lot more energy to dispose of in much smaller spaces needed to store these forms of energy. Or yeah, and this is what kind of began the growth of fossil fuel when the Industrial Revolution started. Then coal stepped in. That's what kind of sparked this entire boom in technology and everything. So, moreover, the reason why fossil fuel was accelerated, right, is due to how compact and easily transportable it is. Um, I mean, it's a given. Why else do we still use diesel and gasoline for our transportation, for our like planes, our cars? Because it's just easy to store and fast to refill. The problem with renewables nowadays, even though they're entering the scene of transportation and they're achieving big strides in trying to eliminate fossil fuel cars, one of their biggest problems actually is the fact that these vehicles that rely on batteries need at least 2 to 3 hours of charging to be able to be used for another, let's say, 400 miles, 500 miles. And that's speaking of the best car in the market right now, as opposed to just combustion cars that you can just fill for 5 to 10 minutes at most and you're off on the road again. Let alone the fact that even with electric cars' slump in prices, with Tesla kind of moving this market forward to let other bigger companies invest in uh, electric cars, there's still a problem of just combustion cars will be cheaper for the meantime, just because it's been in the market for decades and they've managed to make cars as efficient as possible as opposed to electric cars. There are now like shifts to hybrid cars, which people believe will bridge the gap between combustion engine cars and electric cars because it combines the two and you can improve both technologies. However, in the meantime, and in our lifetime, the main form of transportation, which contributes a lot to the CO2 emissions, keep that in mind, is going to be just combustion cars for now. The third point, energy demand has increased immensely due to the exponential growth in human population from the 1850s. There's going to be a graph in the slide that shows how how humans increased their population basically, and there's like an exponential growth, and that happens around the time of the Industrial Revolution, which shows that there's kind of a direct link between having more energy, more technological advancements, and that leads to having more people in general. So the fourth point is the energy demand per person back then around the Industrial Revolution was around 4.85 times 10 to the power 9 joules, and now it's around or even over 77.3 times 10 to the power 9 joules. That is roughly around a 15 times increase from what we were at. So with that being said, obviously you're going to need a lot more energy, you're going to need a lot more forms of fossil fuel burning, everything, just to kind of keep up with that. The fifth point, my bad, is the ability to access, control, and maintain a source of fuel has become a prereq for supporting industrial activity and economic growth. So that's a very interesting point, because the reason why we entered renewables kind of late, or we started investing in it kind of late, is because fossil fuels gave us everything we needed if we eliminate the problems we associate it with climate change. So fossil fuels gave us the energy we need in small spaces, very easy to maintain. At the same time, a big point, which we will cover as well in this lesson, is that fossil fuels are easy to ramp up and down their electricity production. What I mean by that is, as opposed to renewables, which is another thorn in the renewable switch, is that fossil fuels, in general, humans' consumption of energy changes throughout the day, right? When you're asleep, there's just less consumption overall. When you're awake, there's more consumption in general. Electric power companies have to accompany that change. And the reason why we can accompany it in today's world is because fossil fuels are easy to manipulate in terms of how much energy we want to produce. The problem with renewables is that is not the case. Renewables produce as they go. And when I mean as they go, I'm talking mainly about solar and wind. Hydro and geothermal we will touch on in a bit. But wind and solar, they don't produce more because you want them to produce more. They produce more because there's more sunlight or there's more wind. And you can't control that. So that is one big problem when it comes to renewables in that sector. Now, if you want to talk about geothermal and hydropower, let's focus on geothermal, because hydropower can fluctuate in terms of energy when needed. Geothermal, from today's technology, is kind of hard to ramp up or down its production of energy. We can compare geothermal to nuclear energy because they work kind of the same when it comes to how much energy they produce. They produce a constant amount of energy throughout the day, throughout the week, throughout the year, for decades, basically, just like nuclear energy. So you can't ramp it up and down based on the demand of people for electricity. So that's going to be another point. We're going to talk about it. There's going to be slides. There's going to be graphs that I can talk more about in detail. But that's just going to be a big point as to why renewables have still not taken off as much as fossil fuel has, in addition to the years of difference in investing. And then finally, even though renewables don't have the benefits the fossil fuel has in terms of ramping up and down electricity consumption and demand, renewables is being invested in due mainly to climate change. I mean, in the countries met in Paris to kind of agree on how much or how many degrees of Celsius we can want it to increase by 2030, which the US pulled out of, unfortunately. Kind of an ambitious goal to, I think, increase it by 1.5 or 1 at most. But in general, climate change is a big contributor as to why we're investing in renewables. In addition to wanting to become more self-sufficient in energy, we don't want to rely on oil and gas. We don't want to rely on a market that is constantly fluctuating in price. We want something that's kind of stable and that is available even when we run out of fuel, maybe in 100, 200 years of fossil fuels. So the historical role of fuel. Now there's two graphs. The graph on the left is it talks about the energy created, if I'm not mistaken, yeah, and the amount of uh, just the time frame as to when each source of fuel entered. Now, as you can see, right before the 1850s, wood was being used. Wood is biomass, and it's just a modest. It creates just a normal amount of joules, or like just low, not even comparable to all the other fossil fuels and renewable sources of energy. And then when the Industrial Revolution kicked in, that's where coal stepped in from the 1850s. And as you can see, there's an exponential growth. That's until uh, oil kind of stepped in. And the reason for the switch to oil is because even though coal was used to produce electricity and even in trains, oil was just better overall for transportation as it stores more energy. It's easier to store, more energy. There's more energy density in general, and reduces just less emission as opposed to coal or less emissions. Um, Along with oil, natural gas stepped in, and there's actually an interesting point on this graph is that natural gas skyrockets and then is expected to actually increase more than coal, and coal is expected to decrease. The reason for that is because natural gas, in addition to it being having more energy as well and being cleaner, uh, it is not as bad as coal when it comes to just the environmental side of things. And with more countries investing in natural gas power plants, and with natural gas just being energy efficient overall more than coal, coal is expected to decrease. And as you can see, they're expecting a dip. And even in the website, the US Department of Energy website, they even predict that coal is going to slump all the way down to maybe around the renewable level, and renewables are supposed to take over by 2050. But these are just predictions. And then, so that's for the fossil fuels, I guess. Yeah. And then you have hydroelectric, which is a very just not even a lot of energy is produced, mainly because the problem with hydroelectric is because it depends mainly on the geographic location of whoever's investing in it. And even though hydroelectric produces the most amount of energy out of all renewable sources of energy, it is not expected to increase more than what it is at right now, due to just the countries that can invest in that kind of technology have already invested in that technology. So yeah, and then nuclear, even though nuclear is really good, and I personally believe that nuclear can be the way forward if we want to switch as fast as possible away from fossil fuels. The problem with nuclear is you need a country that's stable, you need a country that has a lot of money, the engineers, the scientists for it. In addition to the fact that nuclear waste is still a problem that isn't easily solved. It can even cause like political disputes between countries when you put it at the borders. So that's a whole problem in itself. And just like what we stated in the last slide, nuclear cannot ramp up and down in terms of electricity production. So there's not a lot of betting on it in terms of overtaking fossil fuels completely. So as you can see, fossil fuels are going to stay king for the meantime, and even for the next few decades. Renewables will increase in terms of production, and they might even start knocking out other forms of fossil fuels such as coal. However, in our lifetime, fossil fuels are going to stay in power. Now, the graphs on the right, there's two graphs, one that illustrates population growth and the other one the energy demand per person. Again, just to give you a small visual representation as to how the production of energy increased since the Industrial Revolution, and the exponential increase since that. And in addition to the just global population increase, because with an increase in humans and population, there's going to be an increase in the amount of energy you need to support these people. And as you can see, there's an exponential growth here and there's an exponential growth there. So they're kind of correlated. They're all correlated in the end. So that's the historical role of fuel in general. Now, this slide, as we can see, or as we know, as engineering students or just being part of the scientific community, there's no debate if climate change exists or not. It exists, and there's no debate that it is us as humans who are accelerating the change in temperature. It is true that change in temperature did happen before, but it was never an exponential increase in temperature. It was always a fluctuation between a max and a min, and that's exactly what is currently happening on the left side of the chart, or the left chart to begin with, or graph. Before the 1850s, as you can see, it was just jumping. It was hovering between 7.7 and 8.7, the land average temperature, and that was before the Industrial Revolution, right? Just pretty normal things. And then after the Industrial Revolution, we can see an increase. And then around the 1950s, when oil was kind of introduced and more fossil fuels were used and there's a huge, or like an increase in population, there's just a massive exponential increase. So there's no way we can just deny the fact that we are contributing to this and we need to put an end to it one way or another. And the problem with putting an end to it is renewables right now aren't where they should be today to take over, or at least substitute a bit from fossil fuels. And I believe in this lesson as well, we're going to talk about how geothermal can maybe override solar and wind in certain aspects, and maybe more investment pouring into geothermal can hopefully in the long term reduce our CO2 emissions. And then on the right, you can see a chart or a graph that talks about the CO2 concentration and the years. As you can see, the CO2 concentration, that's around the 1960s. It doesn't even account for the 1850s because the 1960s is the exponential growth, and there's an average increase of about 3 ppm of CO2 per year since oil and gas were kind of introduced into the industrial settings. And right now, the book says it's around 400, but in today's world, in 2018 or 2019, it's around 408 ppm, and it's expected to increase as long as we do nothing and as long as our energy consumption increases, with renewables not being able to catch up to eliminate that. And around the 1850s, I think the CO2 concentration was about 280 ppm. So yeah, this is kind of just to let us visualize the impact our consumption of fuel and our choice of fuel is having on the environment. So, moving on to the CO2 emissions and climate change. This is a graph that talks about, or shows us, which forms of energy, or which forms of energy, I guess, contributes to CO2 emission the most, with electricity generation being the most and commercial residential being the least. Now, transportation, we're not going to be able to properly target, not in the meantime as well, due to the fact that oil and just gasoline and diesel is very easy to use and just is better overall in terms of transportation. So transportation is going to be hard to kind of target. However, geothermal and renewables can target almost every single other column. So electricity generation, which is going to be the biggest one, industrial, residential, and commercial, where we talked about the open and closed loop systems. So as you can see, there is a way, we can solve this problem. We don't have to solve the entire problem, but we can solve certain parts of it that can reduce our CO2 emissions. So yeah, and geothermal mainly ties with electricity generation. However, it can tie with the commercial and residential and industrial parts of things. So ways to reduce CO2 emissions when it comes to electricity generation is reducing the demand for electricity. Now that comes back to us as consumers. I mean, the government can put more taxes, more punishments or whatnot for using more than what you need. However, that comes back to us and just doing things as simple as turning off the light when we leave or whatnot. And as a matter of fact, there was a video that I watched actually that talked about how people in Britain overfill their water kettles. Uh, and like 97% of people in London have water kettles, and like they overfill it. And I think it was 60% of the people overfilled it. And the amount of water that overfilled, that was heated from the overfilling, was enough power to generate electricity for London for an entire day, or England actually, for like the street lights. So it's pretty interesting how small changes in our everyday lives can affect this. The second point is replacing fossil fuel-based electric generation capacity with renewable energy sources. Now, that's the point that everyone talks about, and that's a point where solar and wind is kind of, they're doing their job. It's just not as good as they can, and that's where I believe geothermal can step in, because geothermal has it can just produce 24/7 and can definitely replace fossil fuel generation plants because of how much energy it can produce. And then replacing fossil fuel-based liquid fuels with other forms of portable energy sources. What they mean, or what I mean by that point at least, is by using batteries in our cars instead of just oil and gas, or using hybrid cars that combine both so that we can reduce our reliance on oil. So moreover, geothermal heat can be used directly and indirectly to heat and cool buildings. We talked about that again in the open and closed loop systems, and the video that I showed you guys in this lesson where we talk about how, or they talked about how it was still economically feasible. Second point is reducing electricity demand for heating, ventilation, air conditioning, cooling through HVAC. So basically, this kind of just summarizes the open and closed loop systems and being able to use it. Now, I guess for these next few slides, I'm going to leave it for the last video, and it's going to talk about the energy emissions, how geothermal competes with renewables, how feasible it is, and the reasons for wanting to go into geothermal. So, yeah. Okay. Hello. Welcome back, everyone. For some reason, my videos wouldn't record for the last part. It kept crashing. Something was wrong with my PowerPoint. I don't know, my computer's just failing in general. But before before we start with this last part of the video, this video is going to talk about the geothermal energy emissions. It's going to talk about the feasibility of geothermal energy versus renewables. There's going to be graphs, and there's going to be a point as to why geothermal energy is kind of going to override renewables, in my opinion, and in the book's opinion. And in the end, we're going to kind of just summarize the reasons as to why we should expand into geothermal with some kind of facts and numbers and whatnot. So without further ado, we're going to watch this last video. Now, the reason why I put these videos in general is because these videos kind of help round up the idea of what I'm about to say or what I have said. And it is good just in case I have missed out on like certain information when speaking or whatnot. This is kind of where you should go back to watch. You should watch these videos, because if I was to put quiz questions or whatnot, they're going to come from the some are going to come, if not a lot, from these YouTube videos, just because you cannot confuse what they're saying in a sense. Like, I could maybe mess up in certain parts, or I might say something or might have forgotten to say something, but these videos are going to be concrete kind of textbook things that we can use to get quiz questions out of. So anyways, without further ado, we're going to watch it. So this one, oh, it's already open actually. So the title of this video says, an energy plant with negative CO2 emissions. In general, no power plant does produce zero, or not even zero, sorry, negative CO2 emissions. There's going to be a small twist as to why they say that it's negative, but in general, a rule of thumb is every single process produces some kind of waste or some kind of CO2 emission. So, you know, that's just basic things, I guess. So we'll watch this video and then we're going to summarize it just a bit, and yeah, we'll move on with our last 4 slides or so. Okay, so basically, the negative part of CO2 emissions that they talk about is that they, um, in addition to kind of reducing the amount of CO2 the processing, or sorry, the geothermal plant produces, they will as well get CO2 from the atmosphere and put it back into the system or into the ground or whatever. Now, as you can see, they say that um, they take out 50 metric tons per year, and that's how much a single US household produces. So look at the scale as to how much CO2 we're producing, and look at the scale of how it's pretty hard to kind of reverse if we don't go into more like deeper and more just deeper investments into renewables in general and all of that. Now, moving on to geothermal energy emissions. Um, so as you can see from the graph and from the video actually, they say that geothermal produces like 3% of coal's emissions, and the graph basically proves it. It's pretty negligible at this point. Like, what is that? 50, you could say? 50 CO2 like kilograms per megawatt per hour emissions, as opposed to natural gas, which is around 580, oil around 700, 800, and then coal around like 1,000. So you can see the difference in scale as to why people are pushing renewables. It's not just a small difference in how much CO2 and emissions is produced, it's because it's free, in addition to the massive scale or massive difference in the amount of emissions released. And at the same time, from this graph, you can easily tell why natural gas is expected to take over coal in terms of power plants and production of like electricity generation, basically, because just the difference in CO2 is almost half it released. Oil is going to stay the same, most probably just due to the transportation factor of things. So feasibility now, the topic, we're going to talk about feasibility of geothermal energy versus renewables. Geothermal power plants have historically been viewed and operated as baseload power plants. Basically, just like what I stated, it's they function just like nuclear power plants, and there's going to be a graph. I'm very sorry, I have not maximized it yet. There's going to be a graph showing how it stays constant throughout the year, basically. So that's what they mean by baseload power plants. And the second point is there are different from solar and wind power generating facilities, which are intermittent. Basically, solar and wind, just like what we said again, is that they produce irregularly. They don't always produce 24/7. They don't always produce at the same capacity, so that's another problem. And although all renewable sources of energy have the advantage that they don't require a fuel supply infrastructure to provide energy, power generation from solar and wind is intermittent. So basically, that stacks up to the first point. Then, in addition to it being irregular, seasonal cycles can also affect that. Maybe there's more wind, maybe there's less wind at some point, maybe there's more sunlight, maybe there are storms. All of that can affect the entire renewable point of view on like just generating as much energy from renewables as opposed to fossil fuels. So at the stage we're at right now, renewables are pretty iffy, if that makes sense. They're not at they're not at their best right now. Now there is another topic where you can invest in batteries and they can use these batteries, but that's a whole different dilemma that dives into costs and resources for these batteries and the amount of space you want to put. It's more complicated. So yeah. And then the final point is it states that there's no theoretical reason why geothermal reservoirs could not be managed in a way that would allow it to dispatch more or less energy. So basically, that ties back to the ramping up or ramping down the production of energy. Again, that's a big problem that renewables face, and maybe one of the biggest problems is that you can't ramp it up and down based on the demand the consumer wants, and instead you have to just give out as they produce, and that's the reason why they're not really as good as fossil fuels when it comes to that aspect. Now, the this slide basically has, I think it was California's. Well, what was it exactly? Actually, it was in California, if I recall correctly, around 2011, I think. That was the production of all renewable sources of energy they have. And as you can see, geothermal. When I keep saying where is it, baseload power plants, this is what I mean. They stay at the same level. They never change, just like nuclear power plants. And then you can see that geothermal alone can be equal to the small hydro, biogas, and biomass as well, depending. So like it is a big chunk. It's 21,000 megawatts per hour. Even wind, which is expected to be the third best after hydro. In general, it's usually hydros that are the most, but maybe because the geographic location of wherever that small hydro is isn't producing as much energy. But in general, like wind is always talked about to be a great source of renewable energy, and yet it only produces 12,000 or 13,000 megawatts. And then solar, as you can see, it even just it works for just a few hours a day. So in general, geothermal is the best form of renewables in our like just in general, and due to how much energy it produces and how constant it is. So yeah, and I guess finally, the reasons for wanting to expand into geothermal is fuel is easily replenished, just like what we said. It doesn't really deplete water; it gets put back into the system, as opposed to fossil fuels. No depletion of resources, same concept. Low emissions release to generation electricity, so doesn't release as much CO2. As a matter of fact, just like what the video stated, reduces or releases just 30% of what CO2 does. Sorry, what coal does. It can be locally produced, doesn't require importing energy. Basically, it can be implemented in countries that aren't, just like Puerto Rico, for example, or countries that aren't connected to a bigger power grid or power system, and it can be built or done in smaller scale, just like Iceland, for example, the country Iceland. Extremely flexible when it comes to energy generation. I think that should be inflexible, as in it should produce the same amount of energy throughout the day. So that is a mistake that I should fix right now. Apologies. Basically, just remove it. It produces the same amount of energy throughout the year, basically, day and whatever. It doesn't involve price spikes that are expected from non-renewable sources of energy. Right, because there isn't a lot of politics tied behind it. There isn't a lot of importing and exporting of energy and how much is produced and how much is not produced. There isn't a problem of fluctuations in price, and there isn't a problem of random high surges of prices and sometimes very low surges of price, very low prices, which can affect the production of electricity maybe or something. So it's good in that aspect. And finally, just like what we said, it's available all day long. just consistently. That's what was supposed to be there. So yeah, that's basically everything. We talked about, so basically, what is geothermal energy? We explained how it works, the temperature that's used, and whatnot. There's a video we watched that talks about the three different forms of power plants, or power geothermal plants, yeah, and then the different heat pumps, depending on whether it's residential or commercial, and a video that kind of summarizes all of this as well, in addition to the prices, how oil was expensive. It wasn't even expensive back then, and geothermal was still competitive at that point. Historical role of fuel, talks about just in general how we've gotten into fossil fuels in general and why we are just looking for more energy. And then the CO2, no denying that we are the reason why climate change is occurring, the parts per million of CO2 concentration, and yeah, geothermal energy emissions and the feasibility and why we should expand into it. So hopefully, just like what I stated, the quiz should be a lot of it should come from the videos, just because they're concrete information, in addition to certain points that are included in the slides, and some of the things I have said, such as maybe oil prices or whatnot. So all of these will hopefully be in the quiz. Just watch the videos, read over this, understand, and it should be easy. It shouldn't be that hard. So yeah, good luck.